Problem number 15. The problem says each student in a class writes a different two-digit number on the whiteboard. Okay, so based on the number of different two-digit numbers, the teacher claims that regardless what they are, you can always find three numbers whose digits have the same sum. Okay, so then the question is, what is the minimum number of students in the class? Well, equivalently, what is the minimum number of two different two-digit numbers that should be on the whiteboard to guarantee what the teacher said is correct? Okay, so when you look at this, it's kind of clear. So this is a problem related to the pigeonhole principle. Although in the past, the problem is such kind of problems are usually formulated as we have white balls, yellow balls, and blue balls, right? We have certain numbers of different color balls. Then how many balls do we need to pick in order to guarantee we can get 2 or 3 balls of the same color? So here, the main difference is the color is replaced by the sum of digits. So what I need to do is to categorize two-digit numbers into different categories in terms of the sum of digits, right? So that it can be viewed as colors of balls. Okay, so let's categorize numbers. We know if we have two-digit number, the sum could start from 1, which is 10. 1 plus 0 is 1, and all the way to 18. So that's 99, right? We have 18 categories. So let me write here. This is the sum of digits. So here's sum of digits. So num of two-digit numbers. All right. So let's start from 1, and then 2, 3. Okay, so all the way to, let's say this is 9, and this is 10, 11, then all the way to 18, right? Now, if the sum is 1, then we have only one such two-digit number, which is 10, right? That's 1 plus 0, it's 1. Now, if it's 2, then we have 2 possible two-digit numbers. That's 20, 2 plus 0, or 11, 1 plus 1, right? So here's 2. So this is either 1 plus 1 or 2 plus 0. All right, so similar, we have 3. Okay, so now for 9, we have 9. That's because we can start from 9, 1 plus 8, and then all the way to 9 plus 0. Now, when you go to 10, so here you should be careful. When you go to 10, the number is not 10, just according to you might think, oh, it's 10 by the previous pattern, but it's not 10 because we cannot do 10 plus 0. So this is also 9. Let me put it here. So this is also 9. Well, that's because start from it's 9 plus, oops. So we can start. So you cannot do 10 plus zeros. We have 1 plus 9, 2 plus 8, then all the way, this is to 9 plus 1. So it's 9. And for 11, similar is 8, 7, and for the last one is 1. Okay, so when you look at this distribution, then you can think of, oh, okay, so this is like we have 18 balls, right? So 18 different colors of balls, right? So each one has that number of balls, right? 1, 2, 3, 9, and then 9, 8, 7, go to 1. Now, what we need to figure out is what is the smallest number of students, in order to, which is equivalent to finding the smallest number of two-digit numbers that we need to pick in order to guarantee there are 3 of them which have the same sum. So what we need to do is we say, okay, we just first find what we can do. So what is the, in order to avoid, right? We say, okay, in order to avoid to have 3 numbers that have the same sum of digits, what is the largest we can do? So what is the largest? To avoid 3 numbers with the same sum of digits, right? All right. So obviously, what we should do is, okay, so for the first category, I can choose, let me do here. So for the first category, I can choose a 1. For the second, I can choose 2. And this is also I can choose, that's the best I can do to 2, right? Avoid have 3, okay? So then this is 2, and all the way he has 2, and he has 2, and he has 2, and this is 1, right? So that's the largest number of 2-digit numbers I can choose, so that there are no 3 numbers with the same sum of digits, right? So I get the total equals is 34, right? It's 34. You can calculate 1 plus, which is 1 plus 2, that plus 2, and plus 1, 34. All right, then I get, okay, in order to have 3, then the minimum I need is this one plus 1. Okay. So to get 3 of the same sum, we need at least, right? We need at least is this 34. You need plus an extra 1, that's 35, right? Yeah. Problem number 16. Here we have 4 times 5 rectangles. So in total, we have 20 small squares with the side length 1. The question is, say we randomly pick 2 small squares. What is the probability that they share a common side? Okay, so probability is a fraction. The standard formula is the denominator is the total number of scenarios, and the numerator is the number of valid cases, or we say good cases. Okay, so solution. First, let's recall the general formula. Probability equals the denominator is the number of total cases, and the numerator is the number of those valid cases, right? So this is a general formula. Now for our situation, the total number of cases is just the total number of pairs of small squares, the total number of pairs of small squares, right? Small square means square 1 times 1, right? Okay, so now those good cases, we are looking for those pairs that they share a common side. So this we call the valid cases. Let's, for convenience, let's say we call them adjacent. So here, when I said adjacent means they share a common side. So the number of adjacent pairs, right? Okay. Now, this one is very easy to compute. It's a standard setup to use combination. In total, we have 20, right? We choose 2, so the 20 choose 2. So for this one, is just 20 choose 2. So we have here is 20 choose 2. The key point, so the key step is to figure out what is the number of adjacent pairs, all right? Now, there are different ways to calculate this. What I would do is I'm going to somehow label these 2 pairs so that it's easy to categorize it, okay? So what I'll do is, we know like two adjacent pairs, we have 2 situations, right? So one situation is they are adjacent horizontally. So that's one way. So this we say, okay, so case 1. And the case 2 is they are adjacent vertically. Then let's figure out the number of pairs in each case. Let's do case 1 first. So they are adjacent horizontally, right? Now, if they are adjacent horizontally, what we can do is, so this is 1 pair, so this is 1 pair, right? And this is 1 pair, and this is 1 pair. Okay, so that means on each row, so we just look at on each row. So this row 1, row 2, row 3, and row 4. So clearly on each row, we have 4, right? We have 4 pairs. So this is 4 pairs on each row, and the number of rows is 4. So we have is 16, right? So that's 1, 2, 3, 4, right? Okay, so for each row we do that. Now then let's look at case 2. if they're adjacent vertically, then we look at each column. So maybe here I say this is each row. Now we look at each column. If I look at each column, so if I do vertically, so each column we have it's 1, 2, and 3, right? So we can have 3. So this is 1, 2, and 3. Okay, so each the number of columns is 5. Okay, so in each column we just calculate, we have 3, so that's 15. If you add them together, 16 plus 15, that is 31. So in the conclusion is in total we have 31 adjacent pairs. All right, so this one is 31. Now I put a 31 here. This one we can calculate. It's just 190. 31 over 190. This is the probability. Problem number 17. Here we have a zigzag polygon on the coordinate plane. So on each the horizontal direction, we go 1, 3, 5. That's all the odd numbers. And along the vertical direction, each time it goes up by 2, 4, 6, and all even numbers. The problem asks, say we eventually arrive at a point that's 529 and 506, that's the y coordinate. The problem is, what is the coordinate of the next one after this point? All right, first, let's focus on the y coordinate. So that's the 506. Say the point is right here, right? So 529, 506. For the y coordinate, we know each time to go from 2, you plus the 4, and then next time you plus 6. So we need to figure out like at which place it will go all the way up to 506. If I draw the picture, so this is we have 2, we have 4, we have 6, so we have 8, and all the way we need to add up to 506. Okay. Let's write out the equation. Here 2 plus 4 plus 6, and all the way to let's say this is 2 times x, because it's even number. One of this is 506. All right, so we apply the Gauss formula. This is x times x plus 1 equals 506, right? What we need to do is to factorize 506. You see, if you want to write this as the product of 2 adjacent consecutive numbers, in order to get 6, we can do 2 and 3. Also, because it's 5, the leading digit is 5, so we know x has to be 2 digits and the leading digit has to be 2, right? So combine the two things together from here, we quickly get the x is 22 and x plus 1 is 23. All right, that means we need to go 22 times to go all the way to 506. Now, so let me draw the picture. This is 2, 4, 6, and then we go all the way. All right. So here's 22, so this is 44, right? 44. Now, if it's 44, this is 44, right? So this is 1, 3, 5, okay, and this is 7, all right? This is 43. Okay, so if we go to 44, we have 2 coordinates. We have 2 points. They have the same y coordinate. That's 506, right? Okay, so both of them are 506. So this is 506, and the next one is also 506, right? What we need to do is to figure out which one has the x coordinate 529. In order to do that, we need to add up. Let's add up those x coordinates. So we have 1 plus 3 plus 5 and all the way to 43. And we apply the Gauss formula. We get this is 44 times 11. So that's 484. Okay, so that means this one is 484. It's right here, right? Okay, now Then this is, we plus 45. So this one is 45. So we add 45. This we get is 529. All right. So that means the point is right here. So this is the point we are looking for, right? So I can know this is the point P. So this is the point P. Okay. So now then, what is the next step? So point P is on the right hand side. The next step is go horizontally, vertically up, right? So next step is go vertically up. What we have, so this should be 46, right? Okay, what we should have here, the x coordinate does not change. It's still 250, 29, right? We need to figure out is the y coordinate, that's 506 plus 46, right? Vertically goes up. This one equals 552. All right, so we get the point that's right after this point P is 529, that's x coordinate, and the y coordinate is 552. Right? Problem number 18. We have a quadrilateral ABCD, and we know the areas of three triangles ABD, ABC, and BCD. Now, based on this information, we can figure out the area of OBC. All right, there are two ways to solve this problem. The first method is we are going to use algebra and combined with a very important factor we talked about before. That is, if two triangles, they share the same height, then the ratio between the areas is the ratio between their sides. Okay, that's the first one. The second method is purely geometry, which is kind of in the same spirit, except it's kind of the reverse. That is, if we have two triangles, say they share the same side, then the ratio between the areas is the ratio between the corresponding heights. All right, so let's look at these two methods. Method one, as I said, I'm going to use algebra. All right. For this, I introduce variables. So BOC is what we want to figure out, right? So this item is X is the area of BOC, Y is the area of COD, Z is the area of AOD, and W is the area of AOB. This is kind of natural since the quadrilateral is divided into 4 regions by the 2 diagonals, right? Okay, so then based on the given areas of 3 triangles, we can get 3 equations easily. The first one is ABD, the area ABD, the area is 10. So that is Z plus W is 10. And then we have ABC, the area is 12. Okay, so ABC is 12, so that's W plus X is 12. And then we have, so here we have BCD, the area is 20. Okay, so BCD is X plus Y, the area is 20. Okay, so we have 3, obviously, so we get this for free. We have 3 equations. Then you may ask, wait a second, but you have 4 unknowns, right? X, Y, Z, W, but you have only 3 equations, just purely based on algebra. So here, as I said, now we are going to use a geometry factor. Here you see, we have these 2 triangles, AOB and AOD. So they share the same height. Let's recall fact. So fact 1. Suppose I have 2 triangles. So this is the areas S1 and S2. So this is, say it's the length is L1. And this is the length is L2. They share the same height, right? For this case, this is the same height. So we have the area of S1 over S2 equals L1 over the L2, right? Maybe I use red one, green one. Okay, so that's what we have. All right, so based on this, we have implies Z over W is the same as here's OD over OB, right, from here, okay? and this is the same. This equals y over x, right? So we just apply this factor to two pairs of triangles. Now, for convenience, we can let this one to be k. You say, okay, so then I get a z. I get z equals wk, and y equals xk. I plug this back into my equation. Let's see what can we get, right? We try to simplify the whole thing. Okay, so then I get wk, so that's which, this one is wk, right? So I can replace this by wk. I can replace y by the xk. Okay, so I get wk plus w is 10, and then I have w plus x is 12, and then I have the x plus the xk is 20. Okay, well, so now you see, oh, well, we only have three unknowns for three equations. So we can solve these three unknowns. Right? Of course, we need to find a quick way to solve this. Now, what we can do from here is I have wk plus w, x plus xk. If I write this out, I get w, 1 plus k is 10, and this is x, 1 plus k is 20. Okay, so clearly you see they share a common factor. It's 1 plus k, and one is 10, and the other one 20. So from this, we can quickly get the x equals twice of w, right? X equals twice of w. And then we plug this back into the middle equation, right? Then we quickly get 3w equals 12, so w is 4, and x is 8, right? We get x is 8. So this is, so the first method, as I said, is we use kind of algebra, which is sort of robust, right? We say, okay, we put those unknowns and we set up equations. So at first we say, oh, there are only three equations, but there are four unknowns. Well, then we try to utilize geometry to add one more equation to solve the problem. So when we solve this, the system, what we did is we observe here we have two similar expressions. They have the common factor 1 plus k, and then we just quickly get the ratio between x and w is 2 over 1. So this is what we get algebraically, and then this helps us solve the problem. Now, next we are going to look at method 2, which is pure geometry. Pure geometry in the sense we are going to find this just by a geometry method, all right? So that's what we are going to do for method 2. So method 2. So this is the method 1, which is algebra and combined with what we have talked about before, right? So the ratio between areas, if they share the same height, the ratio is just the ratio between their sides, the corresponding sides. Now let's look at method 2, which is a pure geometry method. Method 2 is a pure geometry. For convenience, I still put x and w to represent the areas of triangles BOC and triangle AOB. Okay, now how we calculate, let's see how we calculate the x. And so the x equals, we notice these two triangles, the AOB and the other one is BOC, right? We see they share a common side, BO. When I calculate the area of BOC, which is 1/2 times BO, that's the common side, and multiply by the height. So the height is I put here, right? So this height, let's say I put this is hx, right? Okay, so times the hx. And then if I calculate the w, which is 1/2 times the common side, that is BO, right? BO, and times the height of right here, so which I say it's HW, right? HW. Okay. Also, I put now. Okay, if I take the ratio now, let me take the ratio of these two. Then I get cancel these two cancel each other. It gives me is hx over hw. Well, this is quite understandable. If you have two triangles, if they share a common side, then the ratio between their areas is the same as the ratio between their heights, right? Quite reasonable. Okay, now let's look at, if I put, let me redraw these two heights here. So this is the HW, and this is the HX. Okay, this time let's look at these two triangles. One is the ABD, so that's the triangle ABD, and the other one is the triangle BCD. Let's look at the two triangles. All right, so how we calculate? So the area, you see the area, again, you see these two triangles, they share a common side BD, right? So the ratio between the areas shall be the ratio between their heights. And the reason is the same. So we have ABD and triangle ABD and triangle BCD share the common side. That's the BD, right? So this is the BD, is the common side right here. I put it, it's the common side. Okay, so then we deduce the area of ABD over the area BCD, right? So this is, let's repeat the calculation. This 1/2 BD times HW and 1/2 BD times HX, right? So we just rederive the conclusion. If they share the same base, we say share a common side, then the ratio between the areas is just the ratio between corresponding heights, right? Okay, so it's the same as the, so this is the HW over HX. Okay. Well, we already know what is the area of ABD, right? So the area of ABD, this is the 10, and the area of BCD, this is 20. Okay, and this tells us the ratio of this is 1,2, right? So 1/2. All right, so we have this one is, if we put it here, which is flip it, we get this is 2/1. So you see, by this pure geometry argument, we rederive the fact that the ratio between X and W, so we get the fact. So X W, so we get the W, we get the X, oops, we get the X equals twice of W. So we rederive the fact. So remember in the previous approach, we derive X equals 2W by algebraic approach combined with another geometry fact we mentioned before, right? You have the same height, then the ratio is between the sides. The ratio between areas is the ratio between sides. So here, by use kind of reversal that if they have the same sides, then the ratio between the areas is the ratio between their heights, right? So this is what we have. Okay. So we derive this the same fact, X equals twice of W, and then of course we combine that X plus W equals, so that's ABC, right? ABC is 12, and we quickly get X equals 8. Okay, all right. So let's recall. So before we move to the next problem, let's recall. So here we use two things, two facts. Let's recall. So two facts. Fact 1: if I have two triangles, if they share the same height, this is, let's say this is S1, this is S2. Here they have the same height. This is the length. Well, I say I call this is L1, and this is the L2, right? So they share the same height. Okay, so then we have share the same height. All right, so then we have the area of S1 over the area of S2. This equals the ratio between corresponding sides of L2. So this shall be L1. So this is first one. Now the next two, if we have two triangles, they share the same base like this. So this is a typical scenario. Or we can flip it. Okay. All right. So then what we have? This is, I say, S1. This I say S2. They share a common side, right? Okay. Then I have the height. The height is H1, and here the height is H2. Okay. So the conclusion is the S1 over this S2 equals, which is H1 over H2. All right. So both formula are actually quite simple. They're both just based on how we calculate the area of a triangle is 1/2 the base multiplied by the height. Problem 19. Jack has ordered 22 lunch boxes from a restaurant for math study group. And there are 3 kinds of lunch boxes. Their prices are $3 per one, $5 per one, and $8 per one, respectively. If Jack has spent in total $140, we need to find all the possible combinations. The best way to solve this kind of problem is to introduce the variables, and we do algebra. So solution. I introduce variables. I say X is the number of $5 lunch boxes, and Y is the number of, X is $3, sorry. Let's put X as the $3. Y is $5 lunch boxes, and Z is the number of $8 lunch boxes. Okay, then quickly we get 2 equations because the total number is 28, right? 28 lunch boxes. So I have the X plus, plus Y plus Z is 22, which is obvious. And then I can also use the information, the total amount of money he spent is 140. This gives me the second equation. So that's 3x plus 5y plus 8z equals 140, all right? So that's all the equations that I have. Now, here the point is we have 3 unknowns, right? X and Y, Z, but we only have 2 equations. Usually, we are not able to, usually there are infinitely many solutions to this kind of equation, which is called indefinite. Indefinite, that means the number of equations is less than the number of unknowns. But here, because we X and Y, Z, they have to be integers, right? So this you can view it as an extra piece of information. And this will help us to narrow down the possible number of solutions. Okay, so how should we solve indefinite equation? This is a system. You can look at chapter for general theory, for general approach. You can look at chapter, I think chapter 12. Right? So there's a chapter about how we do indefinite equations. There's a famous problem. So here we have 2 equations, 3 variables. So there are very famous question in this category. So that's called a 100-fold problem. Right? So it's like someone wants to buy 100 folds that includes chicken, pork, and hams, and each kind has different price, but he wants the total price to be 100. Right? So this is similar like this, right? Okay, so then question is how many different combinations could he have? All right, so to solve for this kind of problem, the general strategy, eliminate one variable, right? So in the book for details, you can look at the book. The book provides 2 different ways to solve such kind of problems. Here, we'll focus on the first one. We eliminate one variable. So which one we try to eliminate? Because here, you can choose whatever you like. But here, for convenience, you see the coefficient of x is 3 and 1. So we choose to eliminate. So here, we eliminate x. How we eliminate x? We multiply the first equation, the equation 1. So let's put this is equation 1, this is equation 2. So what we do is the equation 2 minus equation 1 multiplied by 3, right? So let's see what we have. So from here we get, after we do that, we get is, so 3x, let's do those calculations. So 3x plus 5y plus 8z minus 3 times x plus y plus z, which is 140 minus 66, right? Okay, so this is 74. And on the left-hand side, we combine those like terms. So 3x cancel with 3x. Y we get is 2y. And z we get is 5z. Okay, so we get equation. We end up with equation. That's 2y plus 5z equals 24. Okay, now we need to solve this equation. 2y plus 5z equals 24. Now, one way we do is completely brutal force, right? We say, okay, because they have to be non-negative, so the z can only go all the way from, say, from 0, and cannot go beyond the 16. So I try those numbers. Well, we can simplify that procedure, by notice the z has to be even, right? So here we use number theory. To simplify the solution. So this is also a common trick when we deal with indefinite case. So first we use algebraic approach to eliminate one variable. And then because all the solutions, they have to be integers, then we can apply number theory to simplify the procedure. By the number theory, as I said, this guy has to be even, right? So this one has to be even. So, okay, so z has to be even. Well, if z has to be even, and then of course z cannot be larger than 16. So we get a z, all the possible choice of z. So we say, okay, 0, 2, 4, 6, and all the way to 14, right? All the way to 14, not 16, all the way to 14. Then what you can do is, okay, you just try one by one to find the right solution. Now here, why do we need to simply try? That's because we need to guarantee, we don't want to get negative solutions, right? So things need to check to make sure we don't get all those, we basically need to get the x is non-negative, right? If you put a z equals 0, so it's why z equals 0 doesn't work, because if z equals 0, you get y is y is what? Y is to be 37, and then you get that the x is negative 25, which is invalid, right? So this is what I mean. You need to check to make sure x is bigger than 0. X has to be non-negative. From here, okay, so this is one way you can do. You just check. So this, I put that one as the method one. Okay, you just check. You check. Okay, now method 2. But we can have a shortcut to find those valid x if we use more algebra. So here I put method 2. Use more algebra to simplify, to further simplify. All right. So what I do is this. Look. So here we have, right, I put it here. So 2y plus 5z is 74, right? So the goal is to make sure x cannot be negative. So we have x plus y. Since x plus y plus z is 22, we must have y plus z cannot go beyond 22. It has to be less than 22. Now combine this, we say, okay, look, we can have from here, this is a 2y plus 2z plus 3z is 74, right? Okay, so then I have 2y plus z plus 3z is 74, okay? Now this guy is at most, right? This guy at most, this is at most 44, at most 44. And this tells us, so from here we say, okay, so this tells us 3z is at least 74 minus 44, which is what? Which is 30. Okay, and this tells us the z has to be okay. So 3z is at least 30. So that means z has to be at least 10. Okay. Now this provides us like all those values z. So z is, we combine with number 1, so z has to be even and all the way to 14. Then z has to be no less than 10. If we combine those two things together, we get, okay, we just identify all those valid z's, right? Because z is 10, 12, and 14. So that's all the possible values of z. And in total, we have 3 options. So for example, let's look at if z equals 10, right? So let's look at if z is 10, what's going to be y? So the y will be, so if I put a z to be 10 right here, so 50, 24, so y will be 12. And for this case, x is 0. That means he only buys lunch boxes of $5 and $8. All right. Okay, so now for each z, you just get the plug z 10, 12, 14, and back to the equation, back to here, and then you get a y, and then you go back to x plus y plus z, you get this as x. So my point, so let's quickly review this. Of course, some of you say, well, we don't have to do this because I'm very good in handle numbers. I can tune the numbers to find what I want. Yes, you can do that. especially when the numbers are not that large, you are able to figure that out. But in general, if you have large numbers, tuning number is not so efficient. The most efficient way is what I did here. So this, I think this is one approach, which is use algebra and combine with number theory, right? So the first step is, as I said, step one, so key step, and maybe I should say strategy, is we eliminate one variable. Then we reduce to just one equation of y and z. Now, okay, so then we just, we can simplify to find all those possible z, and then we will plug it back into the equation. Right here, I use the number theory, just, it's a quite elementary way. Z has to be even, right? It has to be even. Okay, so this narrow down the choice. And it cannot go beyond 74, right? 5z cannot go beyond 74. All right, so then we have those choices, but you say you still have 8, right? 0, 2, 4, 14, and you test one by one to make sure that x is non-negative. But as I said, we can also do more algebra to simplify the situation, which, in the sense we don't have to test one by one, right? We say, okay, we just, because the key is to make sure that x is non-negative. So that means we don't want y plus z to go beyond 22. So then if we combine this, these two things together, we get, okay, so 3z, because this part, right, I separate 5z into 2z and 3z. So, okay, so this part can, at most, is 44. And then we get 3z at least is 30, right? So z is at least is 10. Okay, so this is one approach. Another approach is we try to express y and z by x. Okay, so then that also provides a systematic way to solve. For that approach, you can check the textbook. So look at the chapter 12. There's an example called 104 problem, and that presents 2 methods to solve this kind of problem. So one method is what I did here. Problem number 20. This is a geometry problem. We have 2 circles that are tangent to each other. Both of them touch a square that is below them. This problem is kind of off range because it's a typical AMC8 problem. The problem itself is not hard, given that you know how to solve a quadratic equation. Otherwise, it's a kind of challenging. Nevertheless, since this is the last problem of the last assignment, so I think it's not too bad if we use this as an opportunity to look at a typical type of geometry problems in AMC8. That is, we introduce, for that type of problems, we introduce a variable, set up an equation, and then the equation is usually a quadratic equation, and then we solve the equation. All right. Okay, so let's take a look. So I introduce variable x as the side length of the square. So this is x, this is x, x. Okay. Now I draw a large picture. So this is my x, this is x, this is x. So one common strategy we mentioned before, if you see circles that are tangent to each other, or they are tangent to other geometric figures like a line, a square, then what we usually do is we connect the centers of the circle and connect the center with those tangent points. So let's apply that strategy. So here we have 2 centers, we connect them, and then we connect with the tangent point with the ground. And then we connect with the corner, the touching point. Okay. In order to set up the equation, usually what we do is, at least I like to do, is I try to express all those line segments in the figure by using the variable x I just introduced. Okay, precisely speaking, what I mean is this is x, right? So I get this is also x. Because because the radius of the circle is 1, and this is 1, right? Okay, so this is 1. So I get this part will be 1 minus x. Okay, and then I also have this, the whole thing. This is 2, so in the middle. Okay, so this is 1, right? This tells us this part, because this is the middle point. So this part, this is just 1 minus x over 2. And this is a right triangle. Here is also 1 because of the radius. You see, the point is, by doing this, I get a right triangle. I know the hypotenuse is 1, and then 2 sides are expressed by x. Let me single this one out. I have this. So it's a right triangle. The hypotenuse is 1, and this is 1 minus x, and the other leg is 1 minus x over 2. Then we just apply the Pythagorean theorem. So we apply the Pythagorean theorem to set up the equation. Okay, so what we have, so let's write out, so it's 1 minus x squared and plus 1 minus x over 2 squared equals 1, right? Equals 1. Okay, so we need to expand these two things out. For that, let's recall how we expand the square of the sum of two numbers and also the difference of two numbers. So what we have here is a plus b squared equals a squared plus twice ab plus b squared. And we have a minus b squared is a squared minus 2ab plus b squared. So let's apply this to here. All right. So what we have, we get is 1 minus 2x plus x squared plus 1 minus, this will be x and plus x over 2 squared equals 1, right? Okay, so this part is just x squared over 4. Okay, so what we are going to do, the next step is we combine that and simplify the equation. So we have x squared plus x squared over 4 minus 3x plus 1 equals 0. Okay. We multiply by 4 on both sides, and this gives me is 5x squared minus 12x and plus 4 equals 0. This is a quadratic equation. So here we get a quadratic equation because here the power is 2. So this is a quadratic equation. So usually how we solve quadratic equations. So two approaches. One is we use the so-called quadratic formula. So this universal formula tells us the solution of a quadratic equation, or we can use factorization. Or use the factorization. So here I'm going to use the factorization. So we omit the quadratic formula. I'm going to use factorization. So to factorization, I claim I can factorize this as 5x minus 2 times x minus 2 equals 0. It's the same. These two things are the same. You can check. All right. Okay, so well, one way you can just write it out and you can check they're the same. The way that we can get this is we do so-called cross multiplication. I have the 5. Okay, so this is 5 and this is 4. This is 12, right? So I have 5, 1, and then I have 12, 2, 2. So that's 2 times 2 is 4, and then 5 times 2 plus 1 times 2, which is 12, and that's how I. So this is so-called cross multiplication. To factorize it. All right, so from here we get x is 205. Then you say, oh, but there's another one, x is 2, but x is 2 is impossible. Since the height, it cannot go beyond the height of the, it can even go beyond the radius of the circle, right? So this one is impossible. So we get x is 205 is only valid choice. So that's we get 205. Now, of course, you will say, well, suppose, let's say you don't know how to solve the quadratic equation. When you arrive at this f sum, this algebra, you say, I'm okay with the algebra, and end up with this equation. Since this is multiple choice, what you can do is you can just check each number in those 5 options, right? And you find the one that fits the equation, right? So that's one way to do. Okay, so you get x over 205. Now, as I said, so this is a typical kind of geometry problem in AMC10, which is we introduce variable. We use given those, I just mark all those lengths by this variable. Then I come up with something. So here what we have is right triangle, which I apply the Pythagorean theorem, and this allows me to have equation, that's quadratic equation, and then I apply the quadratic formula to solve it. Okay, now one thing I want to point out is if we put this one back, I put this one back into this triangle, let's see what do we have. So I'm enlarging. I have this one because x is 205, so this will just 305, and this will be 405, and this is 1. And you say, wait a second, what do we have? This is a right triangle. The ratio is 3, 4, and 5. And this is very interesting, right? Because everyone knows this most famous right triangle, 3, 4, 5. So here we have an interesting situation where this special right triangle 3, 4, 5 appears naturally, right? So as we said, the right triangle is here. So if we trace this one, It has the ratio 3, 4, and 5. Okay, we can enlarge the picture a little bit. So this part, let's enlarge it to see it more clearly. Right. So here the radius is 2. This you can consider as 2 squares they put together, and there's a small square which is on the bottom. Now let's enlarge the side length from 1 to 5, and this is what we have. Right, okay, so then we enlarge one, let's enlarge this, enlarge the picture, so the middle one, okay? All right, maybe I put this as screen. All right, so now we have it's a 5, 5, this is 5, this is 5, 5, okay? The middle one, which is right here, this is the small square, okay? The small square. Now, here we have 2 centers. So this is the center. So this is the center. And this is also the center. It's the center. If we connect, let's see, if I connect the center with the touching point, okay, so we have 5, what we get, right? So this is 3. This one is 3. So here we have 3, so this is 3. This is 4, right? So this is 4. Okay, so we get this one is 5, and this is also 5. And that's exactly the situation here, right? So my point is that after we know here we have this special triangle 3, 4, 5, and then we can go back to recover this picture by putting 2 squares together, and that this demonstrates this is indeed what happens. Okay, this is the end of our 8-week practice. Thanks again for your participation. This has been an unusual experience for all of us. The most important thing is not how well you have done those exercises. What really matters is that you have been trying, being persistent, and stay to the end. All right, so the summer is over. Have a good fall semester. In particular, please stay safe.